Hello all, today in this video I'm going to provide details regarding and demo video for heart disease classification and also an XAI representation with machine learning code. Already we have done the work with the same data set with some other machine learning algorithms, and in this demo we are going to make with the decision tree and just compare with the other machine learning algorithms to provide an comparison that which data or which algorithm is providing better results with this particular data. Previously we concluded that random forest is providing a better result with this particular data, that is heart disease data. This data we downloaded from Kaggle. So initially for this we are going to import the libraries like OS, warnings, and then NumPy and Panda. Then we are loading our data set, which is heart disease CSV file, and then make it to display its head values. You can see we are getting set of values which is numerical and also float. So mostly here you can see that in the end, that is the last feature or attribute is target. That feature we are going to take as the Y feature or Y attribute, and apart from that everything we will be choosing as the x variable or for x attribute. So then we are getting the info of our data set, whether it is integer or float or any others like string, etc. Mostly we are getting integer and float only, and also we are checking is there any null values. It's not having any null values. Then since our data set is free from null values, we are not moving into any pre-processing stage, and then automatically we are moving to the declaration of x variable and y variable. In the x variable we are declaring, that is we are dropping the target value as I said previously, and for the y variable we are using only the target value, and then we are splitting our data into train, test, y train and y test by using the train test split library, and the test size we are choosing as 0.2, that is 20% will be taken for testing and the remaining 80% will be taken for training. And then as I said previously, we are also making to work with an XAI representation. For that we are importing the line library, and also we are creating a variable like explainer, which is going to consider the feature vectors of the particular algorithm. So then we are also going to display the classification report and also the confusion matrix. For that we are using the libraries which is needed for that. And then previously we have worked with the same algorithms, and also we have made an demo also for from different machine learning algorithms like a random forest. With random forest we are getting an accuracy as 100%, and this is the XAI representation of it. And then for support vector mission we are getting an accuracy of 75%, and also then we have worked with in a naive base. Every of this separate description will be given in the previous video. And for naive base we are getting an accuracy of 85, which is better than support vector mission. So now first is random forest, then is naive base, and then is only support vector mission. And after that we are making a comparison with KNN, which is having an accuracy of 72%. But for support vector mission we had nearly 75% accuracy. So when making a comparison, first we come to random forest, and then it is naive base, and then it is support vector mission, and then it is KNN. And now we are going to see a demo for decision tree, that is DT. For that initially we are importing the library, that is decision tree classifier, which is the library used for that. And then we are declaring that classifier, and then fitting and predicting by for that is testing and training. For testing we are training we are using the fit function, and for testing we are using the predict function, and we are going to display the accuracy score and the confusion matrix. So this is the confusion matrix for the decision tree. Then we can also notice that for decision tree also we are getting 100%. For random for or forest also we got 100%. So mostly this random forest and decision tree is providing the same result, then we are making to display the live representation. For that we are using the explainer variable. By using that we are getting the values like intercept, prediction, local, and also right. Here we have given 7 features, so here we are displaying nearly 7 features and also its values. And we are making to display the j as 15. It can also be like 5, 10, etc. Then since we are having 7 features here, the list of 7 features will also be declared. So this is the code for decision tree with the hard disease data set and XAI representation. In the next video with the same code we will be working with logistic regression. So here by this thing we can just make an conclusion that the first random forest and this decision tree is providing a better results. After that naive base is providing better results, and after that comes the support vector mission, and last in that is we have discussed as for the last comes the naive base, sorry, kn. So in the next video we can see regarding logistic regression with the same data. Thank you.